It's a 2010 question 6 exam question. It looks all very terrifying, but it's actually quite simple. Problem-solving activity, students giving the following information regarding 3 half equations. However, the 3 numerical values of the E0 are correct. Although they're correct, they have been incorrectly assigned to the 3 half equations. So those numbers are correct, but they don't go, the half equations are in the wrong order. So the object of the task is to assign the E0 values to the correct half equations. To do this, the student constructs a standard half cell for each of the half reactions. These half cells are connected one at a time to a standard hydrogen half cell. Okay, so each one of these is connected to the hydrogen half cell, and then the results of that are down here. Okay, the above information can only be used to assign one of the E0 values to its corresponding half equation. Identify this half equation by placing the correct E0 value next to its corresponding half equation. So only one of these. Alright, so first thing, there's a whole lot of information really, and as soon as you see reactions and E0 values, you need to have a look and see if they're in the order that they would be in the electrochemical series. So this is the most positive, it would be the one on top. And then you've got these other 2. Okay, they're also put with the standard half cell, which is the hydrogen half cell, hydrogen ions and hydrogen gas. So that's always 0, the standard half cell here. Okay. So if we put that in order too, that's, we're going to have one that's 0, 0.00, and this smallest negative number is the most positive, and the largest negative number is the most negative. Alright, so we have our 3 equations, and we're putting them all with this. So only one of them is going to have, this is our standard half cell, the hydrogen half cell. Only one of them is going to react with the hydrogen and undergo reduction, where the hydrogen undergoes oxidation. Only one of them. Okay. The other 2 are going to be below the hydrogen. So they would react with the hydrogen ions, and whatever that chemical is there, they would undergo oxidation when they're put with the hydrogen, but they would undergo oxidation and react with the hydrogen ions, whereas this one undergoes reduction and reacts with the hydrogen molecules. Okay, so that's why only one of them can be worked out using this. So the question is, which ones? So when we have a look, so we want something that's going to undergo reduction when it's put with the half equation, with the hydrogen half cell. So this one, the silver chloride, electron flow was detected passing from the standard half cell. So coming from here, electrons were given up to the half cell containing here. So from this to this, so straight away that's the one that we know. Okay, so that is the one that's 0.22 volts. So this one is 0.22 volts. Okay, these 2, it doesn't really matter what information they give you. These 2 will both react with the hydrogen. So we don't know from those reactions which one it is unless you measured the E0 values. So the difference between them, that would get, 6 volts. And if we put the hydrogen with this one, you would get a voltage of 0.4, assuming that they're under standard conditions. Okay, so if you measured the voltages, you would be able to work out which one of these, which one is correct. but they've got no information about the voltages. So the only way that you could work it out is if you put the two of them together. So either measure the voltages or put the two together and see which one. In that case, this one would get the electrons and this one would give it up. Okay, so this is saying that the mass of the cadmium electrode is decreased, yes, because it would react, one of those. The pH of the solution in the standard half cell has increased. So whatever you put these with, the hydrogen ions are going to be turned into hydrogen. So you're removing hydrogen ions. The more hydrogen ions there are, the more acidic it is. If you're removing them, then it becomes less acidic. It becomes more basic. So the pH would increase. Okay, so the next questions are to explain all of that. So explain why the other two E0 values cannot be correctly assigned to their half equations. So because you can't just say, where are the answers? You can't just say, that there was not enough information. Okay, so 68% of people didn't get this because they realised there wasn't enough information, but they didn't explain the type of information that you might have needed. So acceptable responses included both of the other half cells have negative E0 values, but to determine their location, the potential difference to the voltage between them of each would have to be recorded when connected to the standard half cell. Okay. Both of them are below there, but there is not enough information to identify their relative positions, their positions to each other. So the fact that you said that they're below the standard half cell, but there's not enough information to work out where they are, that's more than saying there's not enough information. Both undergo oxidation. That's more to say, rather than just below, saying that they undergo oxidation, but there is not enough information to determine which has the stronger reductant. So as long as you're using some of the language, if you've done them in order and you're using some of the language, then you would get a mark. But if you just say not enough information, then it's not enough for a mark. Okay, the next question was, explain why the pH of the solution has increased. So I've said that already, why the pH of the solution increases. Because the hydrogen, where are we reading here? The hydrogen ions, because you're forming hydrogen molecules instead, that goes down, so the pH goes up. The reaction, that's a reaction that's occurring. Yeah. So it's about 50-50 for this. So these questions aren't that difficult, but you just need to be able to use the language.